Hey, boys and girls, it's Mr. Mack from the Harker School. Today we are going to be combining a couple lessons we've done before with mixed numbers and improper fractions. So today, instead of drawing pictures, we're going to use some calculations to figure out how to convert an improper fraction to a mixed number and how to convert a mixed number to an improper fraction. So I'm going to talk through a couple examples that you can maybe do this mentally, and I'll also have a couple that you'll be able to do by doing the physical calculation. Okay, so for the first row here, numbers 1, 2, and 3, I am going to just talk through how to change a improper fraction to a mixed number, okay? So we have 23 eighths. Now, if you remember watching the video I did before about improper fractions, that means we have 23 of the eighths, right? And we need 8 eighths to make a whole. So in my head, I'm thinking to myself, well, how many eighths can I have go into 23 without going over? Okay, so I know that I can have 2 eighths because that's going to give me 16. Because if I had 3 eighths, that would be 24, and that would be too much. So now I know that I have 16 of those eighths. Well, how many more are left? So 16, 17, 18, 19, 20, 21, 22, 23. I have 7 more of the eighths left. So that leaves me with 2 and 7 eighths. Okay, so again, I'm going to do a couple of these just by talking it out, and maybe it'll make sense. I'll do a couple of these where we do the actual division, and that might help you out too. So just want to give you a couple of options here. All right, so again, how many sevenths do I need to make a whole? I need 7 sevenths. So how many times can 7 go into 47 without going over? It can go in 6 times, because 7 times 6 is 42. And how many more do I have until I have all 47 of them? 5, because 42 plus 5 is 47, and my denominator still is sevenths. All right. 2, I need 2 to make a whole. So how many 2's can I have? I can have 2 of those, because that's going to give me 4 of the halves, and then 1 more makes 5. Okay, sometimes people get confused when there's a 2 on the bottom. That is called a half. So if I had 5 over 2, that's actually considered 5 halves. All right. Looking at the next row, instead of just talking it out and saying this is how mentally you could do it, I'm going to show you how you could do it using actual division. All right, and we've learned long division before, and if you haven't, you might be wanting to go and practice that online and watch a couple videos on doing the long division. All right, so we want to know how many 4s we said can go into 15 without going over. Well, that is just 4 into 15. All right, 4 can go into 15 3 times without going over. 4 times 3 is 12. I subtract and I get a 3. That remainder is going to be how many I have left, what part of the whole I have left. So I have this 3 up top, which is my whole number, because I have 3 full fourths. 3 is my remainder, which becomes my numerator, and my denominator always stays the same. Okay, now that one's a little bit tricky and a little bit confusing sometimes, because we have a 3 here and a 3 here. Let's try another one. I'm going to change my color too, because I want to make sure that we're able to see it. Maybe I'll try yellow. All right, 37 sixths. So if I said, okay, I need to divide 6 into 37. All right, 6 can go into 37 6 times without going over. And then I subtract, because 6 times 6 is 36, and I get a 1. So this is going to be my whole number again. So I'm going to put my 6 here, all right? And then my remainder is my numerator. It's a little tough to see. And my denominator always stays the same, which is a 6, all right? So at this point, I'm actually going to you're going to pause the video, and I want you to try number 6, doing the division. All right, so now you're going to pause your video now and give it a shot. And when you unpause it, I'm still here and I'm ready to rock and roll and go over number 6 with you. So 25 fourths. So I'm going to say 4 goes into 25 how many times? All right, so 4 can go into 25 6 times. 6 times 4 is 24. Okay, I subtract and I have 1 left over. That 1 is my numerator, and my denominator stays the same. So my answer would be 6 and 1/4 there. All right, so that's two different ways that you could do this mentally and by showing the actual division. It is the same thing, except I sometimes like to show my work and do the division so that I can catch a mistake I would make. But as you get older and you get better with this and better with this and better with this, the mental math way is a good way to kind of check your work there. All right. So instead of having you do another row, those examples are there in the post in the links that are with this video. Sorry, my tongue was tied. With the links that are posted with this video, there'll be plenty of examples, and this actual page will be there so that you could check your work because the answers are going to be on this page below. All right, I am going to erase the work that we had here, and I'm going to slide down because this is just not going to be improper to mixed. We're also going to be converting mixed numbers to improper fractions. So it's in the other problems we were dividing. So if we're doing the opposite now, we're changing from mixed to improper. We're not going to be dividing. We're going to be multiplying. Okay. And what we do is we multiply the whole number by the denominator. Well, why do we do that? We multiply that because we know that there are 2 parts that make up every whole. Okay. And we have 8 wholes. So I need to know how many parts that's going to give me. All right, so that gives me 16, right? 8 times 2 is 16. That is 16 represents 8 wholes, okay? Gives us 16 halves. They're the same thing. So 8 times 2 is 16, and then I add on my extra one that I have here to make 17 over 2 or 17 halves, all right? So again, we multiply these to find out how many parts make up the 8 wholes, and then we add this one on because this is a part that needs to be combined with what we have already done. All right. So if I was talking about drawing a picture to kind of go over this, which could help you, all right. If I have 8 wholes, that's 1, 2, 3, 4, 5, 6, 7, 8, right? If I have 8 wholes and they're all halves, right? I have a half, half, half. Ooh, that half's a little rough. Sorry. Half, 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 and half. How many halves do I have? I have 16. So that's why I'm multiplying the 8 times 2 to give me the 16. Okay. And then I have my extra half here that I'm adding on 16 plus 1 to give me 17. So that's where I'm doing this work from. So understanding why you're doing this is really important. It'll be good for you to know how to do it quickly. Okay, I multiply that and I add and that's it. But this is more for you to understand why you're doing it. All right. So when we look at 3 2/5, all right, 3 times 5, again, because 3 wholes, each whole has 5 parts, gives you 15 parts, and then add on the 2, that's going to give you 17. So that gives you 17 of the fifths. All right. And again, if we were to draw this picture, you would have 3 wholes, 1, 2, 3, and they're all fifths. So 2, 3, 4, 5, 2, 3, 4, 5, 2, 3, 4, 5. Sorry, my parts aren't exactly correct, right? And then we have one that is 2 of the fifths. So 2, 3, 4, 5. It's just these 2, right? So we have all of these 5, 10, 15, and then these 2 make 17 of the fifths. So again, that's why we're multiplying 3 times 5 because each of these wholes have 5 pieces. All right. So then again, 5 times 7 is 35. I'm not going to draw this one because that would be a lot of drawing, but just know that there's 5 wholes, like your fingers, and each has 7 parts. So 7, 14, 21, 28, 35. And then 2 here makes 37. Okay. over 7, which means we would have 37 sevenths if we did that. All right, so at this point, I'm going to pause the video. You're going to pause the video, excuse me, and you're going to try numbers 4, 5, and 6 to see if you're able to convert the mixed number to an improper fraction. So ready, set, go. And I'm still here after you unpaused it. So again, quickly this time, 2 times 7 is 14, plus 2 is 16, okay? And then the denominator is 7. All right, and then here, 6 times 2 is 12, plus 1 is 13. All right, and then the denominator is 2. And then 2 times 3 is 6, plus 1 is 7. And the denominator is 3. All right, so that's how we convert mixed numbers to improper fractions, and we showed before how to convert improper fractions to mixed numbers. Again, this is one of those videos that it might take you a couple times to watch and understand to really figure out how to do this. I'm hoping that the drawing of the pictures helped. I'm hoping that the previous 2 videos that we had posted about understanding what an improper fraction is and understanding what a mixed number is were there to help you in understanding this lesson, because they were kind of warm-ups to what this one was going to be. If you need more help, there's going to be links provided with activities and games, and make sure you utilize them and do your best. All right? Take care, everybody.